knowledge of Docker, you don't need to worry about. This is where you start. It's a beginner guide, and also expand to the advanced level. Okay.
Hello, hi Sidhu.
Hi, Anjali. Yeah, I think so. I disable the unmute option. Let's not speak in between the call. Let's finish the presentation. So if you have any questions, please put it in on the chat. Okay. So you can see my presentation, right? So the first slide is just about explaining about what is the Docker, right? So Docker is it's like an open source platform. So it's basically shipping your application, or running application as a container, right? So it will ship, like it will bundle with all your required libraries and your application, and you can host on any platform, right? It's a platform and cloud agnostic. So it's the same Docker image can be deployed on your Windows or Linux machine or your Mac machine. Okay. So this Docker will enable the containerization. So when I say containerization, like you heard about container, right? So where you bundled everything and then deploy it. You don't need to like depend on any other libraries. Okay. And it's very lightweight, it's portable. As I said, it can be deployed on Windows machine, it can be deployed on the Mac machine. So if you want to run Tomcat server, right? So you can create a one Docker image. That image can be deployed, like installed on your Windows machine or Mac machine. Okay, so then Tomcat server will up and running. Okay, so it also ensure the consistency across the environment. Means like once a Docker image created, so that it won't be changeable. It's like it add all your parameter configuration to Docker image. So then when you deploy to any environment, it will get consistent all the environment configurations. Okay. So the next one, why we need to use Docker? Okay, as I said, it is portable, it's very lightweight. Okay, and you will get a consistent deployment. Okay, so and also it reduce the configuration conflict, right? All the application bundled with its own libraries. It doesn't depend on any other libraries, right? You don't need to install any shared libraries for multiple applications. So which I'm going to show it in the next slides. Okay. But before that, like what is containerization application and what is the difference between virtual machine, right? If you go back to the world, like before virtual machines, you used to have one server. Like even if you take your home desktop, right? You install multiple applications, right? Sometime multiple application, sometime one application may not work because it's conflict with another library, right? If you take in the corporate network, right? So you have a servers, right? So there the next technology came is the virtual machines, right? You were creating a virtual machines over the single infrastructure, means single hardware, right? So you have a very big hardware like 32 GB, 256 GB RAM or whatever, like 32 vCPU. Then you need to host hypervisor on that in order to create multiple operating system. Okay. So if you look at the screen here, virtual machine app A, virtual machine app B, virtual machine app C, right? So how do you achieve the application isolation and conflict? You have to end up with creating a virtual machine per applications, right? Virtual machine I can carry operating system, right? You keep on updating your virtual machines to comply with your securities, right? So the what Docker introduced easy way to manage your application deployment, right? Instead of you creating multiple virtual environment, like virtual environment per application, you can create a Docker image per application, right? Docker image doesn't carry kernel. So the difference between Docker and virtual machine is virtual machine, it has its own kernel, right? Docker image, Docker engine doesn't carry the kernel, right? It has all the required libraries, right? And plus application, right? It's bundled it as a like artifact. Then you deploy it to any environment. So here, if you look at the containers application, right? Application A, application B, these are the Docker images. So that is sitting on one host operating system, right? So let's say if you upgrade something library and host operating system, that will not impact your application A because application A is already bundled with all the required libraries. So you can feel free to go and update the operating system. Okay. So this will provide efficient resource usage, right? You can dedicate, like you can split this, let's say host operating system has like certain configuration, right? 32 CPU, 256 RAM, right? This may not need, right? All the application may not need the so much of memory. You can dedicate certain memory to application A, so you can efficiently use the resources. Okay. Okay. The next is the most important. Let's like if you have any questions, please put a questions in the chat. Okay, here. So key concept in Docker. So as I mentioned, like again and again, images, right? Image is nothing but blueprint for your container, blueprint for your application to be deployed, right? When I say blueprint, let's say if you want to deploy some Java application, right? Java web application, which is required Tomcat, which is required certain user, which is required certain libraries. So that is you define a blueprint for it. Okay, I'm gonna deploy this Java application. I need a Tomcat. I need a so and so library, OpenSSL library. I need a certificate managers. Then I need to create a users. This is called blueprint. Okay, so here these images when they deploy to the container environment, it is called containers. Okay, you can see here images and then containers. Once you deploy image, it's called a container, right? So this Docker file, this is where it's kind of a script to like represent your blueprint. Okay. So here you give instructions what needs to be bundled. Okay. Docker Hub is a registry where you publish your artifact. When I say artifact, it is Docker image is an artifact, right? So Docker Hub is public one. If you go to corporate network, you might be having ACR, like Azure Container Registry. If you're using AWS, you have AWS ECR, like Elastic Container Registry. And similarly, Artifactory has its own container registry, and Nexus also is artifact repository that also has its own container registry, right? Okay, so basic Docker commands, these are the Docker commands, Docker pull. So in order to pull image from remote repository, and where like if you created a Docker image, publish on to the any of the remote repository, so you'll use Docker pull. Second, Docker images to list your images on your local laptop. Okay. Docker run, you're gonna run the application, means you're gonna take the image and you're gonna deploy it. You use the Docker run command. Okay. Docker PS is like list the running process running containers. Okay. Docker stop, if you want to run the already started container, you can run the Docker stop. The most important is the Docker build is the command which is used to build the image. Okay. So I'm going to show the simple example. So then we can recap these slides again. Okay. Let's go back to my Visual Studio Code. Okay. So I have Ubuntu. Let's say you have Windows laptop. Would you be able to run Ubuntu server? It's not possible. If you have a Docker, it's easy to deploy Ubuntu machine and any application on it, and then Ubuntu like the machine in your Windows laptop. Okay. So right now I'm using my Mac one. So I'm gonna run the Ubuntu here and show you, right? So as I said, the Docker file is like basic representation of your blueprint, right? So Docker file is the entry point for your any of the Docker images, right? You in a Docker file, you say it's simple script. Okay. Don't worry about all these commands. I'm not going to explain. So I'm going to explain the next slides. Here, just to give example from Ubuntu 22.04, right? So already someone created a Ubuntu image and put it in a Docker Hub, right? So I'm going to pull this one, okay? Then so here, this Docker file is going to install certain like a wget library, and then the create the user and then run it, okay? So let's go to the commands. Okay. I'm going to go into this directory, copy path. Okay. So in presentation, I shown you the command list of command, right? So here, if you go Docker build, I'm going to use first Docker build, right? So it will build basically image. Okay. So -t means you're giving a tag, right? You're giving a name to the image. If you don't give it, it randomly generate. Okay. Let's say Docker build -t. So I'll say my Ubuntu, right? My Ubuntu colon, I can give version 1.0.00, right? Then dot means where the Docker file located. So if you give the different name other than Docker file, if you give something else, Ubuntu file, then you need to mention -f and file name. So if you give dot, it will try, by default identify any Docker file name and try to build it. Okay. So first, what it does, it's gonna pull the Ubuntu machine from Docker Hub. So it started installing the updating the my image, and then install the wget libraries and just remove the cache. And then so you can see here it's user added, it's app user, then working directory, then Ubuntu Docker image is created. Right. So the next command, in order to see the image which is created, right? What is the command you use? Docker images. Okay. Docker images. Can you see the Docker image machine here, which I just few minutes ago I built, right? So the next one is Docker run. I'm going to run it, right? So Docker run. So if you put Docker run help syntax, it will give you all the like the command it accept, right? Docker run -it means I'm making interactive, right? Either you can run this machine in a background, you can connect later. So if you want to run in a background, you just mention as D, -D means daemon. That means it will run as a process. Then you can connect it. Okay. I'll show this also. Let's say Docker -D. And this is a Ubuntu machine I'm running, right? So the one important when I run it, it keep running, right? So if you see next command is docker ps, right? It will show what is the container running. Can you see here? This is the command I used. Okay. So right now, since I mentioned -d, it's running in the background, right? So let's say if I want to connect it, right? You need to use docker exe. Let's not worry about its advanced level. So I'm gonna kill this docker container, docker stop. You just mention the container ID, right? So that's a docker stop command. Okay. It stopped. If you see docker ps again, you don't see the image, right? So now I'm going to run in the interactive mode where I need to log into the machine and do certain things, right? So same thing, Docker, when you run the Docker run, I just mentioned is -it is interactive mode, means it will straight away log into the session. Okay. So how to log in? I use a bash terminal. I just mentioned a bash. Here you go. It's logged in. Logged in as an app user, right? So if you mention uname, it will show what is the operating system. It's Linux. You can see it's a Linux toolkit because Ubuntu is in Linux, right? So this is very simple Docker container which I run for Ubuntu. Okay. Let's exit from here. Okay. So I just wanted to run through these commands. These are the frequently used commands in even in your corporate office also. You're not going to use multiple advanced one, but these are the frequently used. But in office, like if you go to corporate network, you don't run is Docker run like this here, right? They have a different layer of managing container. It's called Kubernetes, right? So I'm not going to cover Kubernetes right now. Today is just a session for Docker. Okay, that reason I'm running Docker this container in my Mac laptop. Okay. So the next one is most important. That's the last one. Docker best practice in summary. So before that, Docker file I'm going to explain, right? So if you look at the Docker file, it has the from syntax, right? From means take a base image, and from there you start building your own image, right? So base image usually, in the last example I shown Ubuntu, nobody pull Ubuntu. right? You don't need very big Ubuntu machine to run any of your Python or Java applications, right? So there are already official Java image been created by like community, or Tomcat is created by Tomcat official images, right? You can pull it from there. So basically you need a base image. From that you put all your applications. So every Docker file you see this from, right? But if you don't want to do it from the from, you need to build your base image. How do you build using a scratch, right? So that's very advanced level. Let's not worry about in this session today. So we'll just take it from like a use the from image to pull the official image. Okay. Next, labels. You're just giving a labels for your image, your container. Okay. Just add a metadata information. Okay. The argument, like when you're building a Docker file, you might certain times you need some argument to be passed. So for example, let's say you're building a Tomcat application, right? So Tomcat application, you consume a from like Tomcat official image, then you need to inject your war file. That's the executable file, right? So that comes as an argument. It's a simple example, right? When you're building Docker file, you pass this parameter, those called arguments. Build parameters called arguments, right? These are the Docker file syntax, okay? So you don't need to remember everything. Um, so like when you start working in real world or you start practicing, you'll automatically remember. Even if you don't remember, you can use any chat GPT or AI tools in your Visual Studio. Just ask to build, it will build. Then you just arrange accordingly. Okay. So the next one is env. Is env nothing but it will create environment variable for the Docker container, right? So for example, Tomcat, like it requires some Catalina home, Java home. So those are all can be defined using env parameters. Okay. So the next one is the run parameter. The run is used to run any commands. Right? If you want to run any commands when you're building your images, you mention those run one. Okay. The user, you'll say what user it has to run as container, right? When you run Docker run command, so if you see right, when I run the Ubuntu machine, it logged in as app user because I mentioned user as a app user in my Docker file. Okay. So working directory, when you run a Docker, what should be the working directory? Like what is a like when you log into the Docker container, it give the path, right? That's called a working directory. That's where it starts. Okay. So I think run is duplicated two times. It's the same thing. And then add and copy these two, copy the files from your source to Docker image when you're creating. Okay. Add is remote files. You always should use copy. Don't use add because add is certain. Sometimes it's called downloading from internet, downloading from web, right? That's where you use add, but that will carry certain permissions or vulnerabilities. You don't know that. Okay. Expose, like you don't need to, like when you run a Docker container, there's multiple ports will be open, right? So you don't need to expose all the ports. If you want to expose only one port, you can use expose syntax, right? Or env is duplicate again. Entry point and CMD. Entry point, like when your Docker run, what should be the entry point? What should command you should run? Okay. So that's a entry points. So if you go to my Ubuntu file, right, I may not cover all the command, all the syntax here. If you look here, I cover the from, right? The from means take the Ubuntu machine, run certain commands in my Ubuntu um, image, like when you're creating. This one run means user add command it's running. User means when you run a Docker image as a container, it will be logged in as a app user. So this will be working directory. This is the command which will run, right? So if you go back here, run it again, Docker run, right? When you run it with a bash, you can see this app user, right? So this app user get from here means when you run a container, it has to be app user. You can't run as a root user. Okay. So similarly, the next one working directory, like if you do PWD, right? Present working, this is a working directory. Means this is coming from here, this syntax. Okay. Let's say I'm gonna comment it out. I don't want to pass user. If I don't pass it, when you run a container, it will directly log in as a root. So if you see here, I'm running a Docker container, it is a app user, right? So I'm gonna exit. I'm gonna build the container again. Okay. because I made a changes, right? It's a new one, new image needs to be created, right? So I'll give it as 1.0.1. Okay. Now I'm going to run um, the latest, the next version, right? Run 1.0.1 bash. When you hit, I think it is, oh, it's not saved. Okay, let me save it, then create an image again because my file is changed. I'll make it as 1.02. Okay, so I'm going to run it as 1.02. It should log in as a root. Can you see the difference? Login as a root, right? In corporate network, you shouldn't run as any Docker as a root. Okay. So as I said in the first slides, right? The difference between VM and the Docker, right? So Docker doesn't have any kernel. Okay. Kernel is required to communicate with your hardware and your applications, right? Operating system. So virtual machine is, if we say each virtual machine has its own kernel, right? So why we shouldn't run this as a root? Because so if you run as a root, this might get the access to the host operating system, right? Kernel, it gets access to the kernel and all other Docker running on the same host platform get compromised. Okay. So I'm going to put this back as it is, save it. Okay. Let's go to the presentation. Okay. Okay. So the next one is security best practice. The first one which I covered, do not run container as a root. That's I said it will one Docker image like container compromised. So all your host operating system is compromised because it use underlying kernel of host operating system. Okay. So that's the most important. And second one is executable owned by root, non-writable. Means any Tomcat you installed, any applications you're running should be owned by root and it should be non-writable. So only non-root user, app user should only be able to execute. You should not own any executables like Tomcat binary, Java binaries, or any other binaries. Okay. Next, avoid binding UID to specific UID. This is UID is not if you haven't worked on Unix platform, it is a then it will be new. It's like a unique ID for your any user, right? So here, if you go back to the my script, right? I created a user add app user, right? So instead of I could have mentioned unique ID 1001, right? So then it will create a 1001 user, right? So you should avoid it because you won't be able to override when you're deploying it. Okay. And use the trusted base image, official images only. So even if you go to Docker Hub, you have trusted images. Okay. So for example, let me log into Docker one and I'll show you. If you go to Docker Hub, this is a public one. Okay. So you can go and search official image. For example, I want to see Tomcat, right? So there are so many images, right? Tomcat, Bitnami, and there are so many people have created their own images, right? If you open this one, like let's open the first one. This is it says official Docker official image Tomcat. You need to use official image, right? Similarly, in corporate network, you have official image for each and everything, like Python, Java, they have official image. Try to use that because it's not created by any community. It's created by your own corporate engineers. They've embedded all the security guardrails, right? So they resolve all the vulnerabilities. Okay. So the next one is do not store any credential images because image is portable. If your image get compromised, if anyone get hold your images, they can install on their own laptop and then they can run it and get credentials. You should not store any credential images. Okay. So for example, credentials say you're creating an API, you need to connect to Open API, the portal, right? You need a token, right? So token should not be stored here. So there's a better way to handle it. That will be a separate session, but just for your, in one word, shouldn't use credential in images. The drop unnecessary Linux capabilities. So you can make uh, you can do some research on what is Linux capabilities. There are so many Linux capabilities like use underlying network. There are so many capabilities you don't use it until it is required. Okay. So the next one is efficiency about maintainability of your Docker images. So use minimal base image. So as I said, nobody use Ubuntu images. As I said, Tomcat, right? You don't need to use Ubuntu install Tomcat. You directly consume Tomcat image, right? And even if you take Python, if you're running a Python, Python also has many images, right? In that slim images, you can use only slim image to run your any Python application. You don't need to use very big images, right? Use minimal base official image and use multi-stage builds. This I'm going to cover in the next step because multi-stage is nothing but you build the application and straight away consume it. Okay, then create a image out of it. So don't worry about multi-stage. I'm going to explain it in the next slides. Expose only required port, right? So I'll show you the example. Say for example, I'm running a Python Streamlit application, right? So if you see here, you might be having expose command here, right? Expose port 8080, right? So if you don't put this, what will happen? All the ports get exposed, right? But that's not required. Your application running on port 8080, you should only expose port 8080. So do not expose all the ports. Just use expose syntax to expose only particular port. Okay. And regularly update your images. You do whenever you consume, make sure that you update the image and then like the add your application over it. And the layer sanity is most important. I'm going to cover that in the next, like when I'm explaining the live one. Layer. Let me go back to the example. So this each syntax is called as a layer, right? So this sanity check, layer sanity is most important. If you put more layers, your Docker will take more time to build it, and also every time you change small layer, so it will entire Docker image will build. So for example, let's say I have a run layer. This is called one run layer, right? So you run a version one, right? When I'm running version one, it took more time, right? So when I'm running a version two, it didn't take much time. It's just like within few seconds done because it will cache all the layers, right? So it will check only which layer is changed. So it will build from there. So for example, here if I change to app 2, right? So already assume that already I built a image. When I try to build again, it will start from here. Okay. And you don't need to, like for example, you need to club uh, the commands into one layer. For example, this one can also be run as another run command, right? You can run it and run this one also, but it will create a multiple layers. You don't need that. So you need to merge your commands, make it a single layer. Okay, so that Docker image will be faster and the efficient. Okay. All right. So metadata and label should be added. Meaningful tag should be given. Don't give the name. Like for example, building a Tomcat, any of your application, give the app name, service name. Use a proper tagging. Okay. So the next one is tools and commands. You need, as I said, do not use copy or add. Okay. Add is used to pull the file from the remote, right? Means the a website from API. So when you use add command, what will happen? It will also pull all the permission along with that. Instead of add, you can use run command to wget or curl to get the libraries. Okay. Completely avoid add. Okay. Copy is basically copying the your files, putting into the your Docker image. Okay. So Docker ignore is use the Docker ignore for sensitive files, and also you can avoid adding the unnecessary files into Docker image. Okay. Lint Docker file with header lint and the scan images Trevi. These are not the open source tools. If you work in corporate network, they use these kind of a tools. Okay. So linting Docker file basically check your all the syntaxes and the format of your Docker file, right? If any issues or warnings, it will highlight. And Trevi and other many other tools are also there. Even AWS provides its own ECR scanning tool. So they give the any vulnerabilities identified. It will also label it as critical, high, and medium. And the third one is Docker build. Like -t is a tagging. So these are the tools and commands we use. Okay. So next one is most important. After that is the question answer. Okay. So I'm going to exit. So I'm going to take the production based application. Okay. So this is one of the production based, this Docker file is completely explaining production based deployment. Okay. This is how your Docker file when you work in your real corporate network. Okay. So I'm going to explain all the like best practice what I followed in this Docker file and Docker image, and also I'll deploy and also show the application also, right? Let's start with this repository. So this is a GitHub repository. This is a public repository. You should be able to access from like anywhere and just clone it and you can run it on your machine. Means the first thing you need to install Docker engine, then take this and just follow the README file. Go through the README, then you can state up and running your Streamlit application, right? Similarly, you can run database on your Windows machine like Postgres, MySQL, Tomcat server, anything you can run on your laptop. Once Docker image killed, Docker container killed, your machine is clean. You don't need to install anything on your laptop other than Docker engine. Okay. So I'm going to run through the first, just give the overview of the application. So I have developed a Python-based Streamlit application. This is my web application. It just give, I just used NumPy pandas library so that to demonstrate properly this use case. So this Streamlit application is just to give the some input box and then give the some chart. Okay. So the objective of this today's session is not to give the training on Python. It's just a simple example which I've taken. You have well experience in Java, any other tools, you can use it similarly, you can build an image for it. Okay. So I'm using a Python here. So the next one is Docker file. This is most important. You can see they're multi-stage. You remember I was put a point multi-stage, use a multi-stage build in the security, right? So this what happened, this multi-stage is one stage is to build, right? So here Python is building, but if you Java, you can run Gradle, you can run Maven, Apache Maven to build your Java. Then straight away inject into Docker image. So this section does the build step of your application. Here in my Python, there is no Python. There is no Python is a dynamic language, right? You don't need to compile it, right? Or you might be asking question, why you're going to build it? So build means I'm not building any library here. What I'm building is the virtual environment, right? Python virtual environment. That is something you can do more research after this class. So I'll create a virtual environment, then I copy my all the libraries, like the application into it, right? So that is my build process, right? If you look at the build from image, I've taken very small image. I've not taken the Ubuntu, I've taken the Python, again in Python 3.11, again in 3.11, I've taken Slim, means I just need a simple Python engine to run my Python application, right? So I label it as a builder so that it can be consumed later. Okay. So these are the labels. I just say it's my app, it's version, Streamlit application. It's just a license MIT. I've just given the um, image source. It's just example. Okay. So then this environment name, you see, I've defined Debian frontend as the variable. This is the non-interactive is the variable key value. You can define any Python path also, you can do that. Say for example here, you can put, if you want to add any other environment, you can add it here. So I'm going to explain, I'm also explaining the syntax also, right? The run, so when I pull this image, basically I want to update the image, right? So apt is nothing but is Ubuntu image. So I'm running apt update the image, install the recommended like libraries like build essential required to run my application, right? And curl command I need, right? And then I'm cleaning up the cache. Okay. Working directory, when this stage runs, it has to work on this directory and then copy requirement. Okay. Requirement. Let me explain what is requirement. Requirement is nothing but these are the libraries required, Python libraries required to run my Python application, right? So go to Docker file and then it is copy the file. Copy command is copy requirement file into my image when I'm building, then run this command to create my artifact. Okay. So once it is done, copy the source to the source directory. Source means this is the entire main.py get copied into Docker image. So the next one is the runtime. This is where the image get creates and it will run. Okay. So work directory I mentioned, it run as the work directory, it run the same commands, it's going to build the image. And also you can see here, I'm running as app user. I'm not running as a root user. This is the most important security guardrail you have to follow. No Docker image should run as a root user. So there is no app user exist. So I'm creating a app user using app user run command, then switch to app user. Any command below this run as a app user, not root user. Okay. So then I say copy the env, copy the app directory from the builder stage. This is a builder stage, right? Whatever the build here, that will get copied to my final image. Then give the run command to give some permissions, and then the expose only port 8080. And these are my environment variable required to run my applications. Okay. Then cmd is final. When you run a Docker image, this is a command it runs. Okay. So if you follow the README file, first step you're going to do the create the image, right? So let's go to this directory, copy path. Let's exit from my container. I'm going to clean my session. Yeah. So cd to the directory, you can see those are the files exist. Docker file is the one. So I'm going to build the Docker image now. So just copy paste this one, my app Docker one. Yeah. So you can see this is called every layer, right? It's because already I built this Docker beforehand, so it didn't like install everything, right? It layers are captured, right? So it's straight away built. It just take few seconds. Let's say I don't want to use cache one. I say no cache. So it built from scratch. No cache is another text. See, it started building everything. Every layer it will build. So 3 of 8 layers. So if you go back to here, so this all the if you go back to these layers, it will count as these layers. 8 layers. Builder one. Then runner is different. It has other layers. It will build both. Right now it's building builder layer 2 of 6. Okay. And you've seen, right? I've not installed any Streamlit, NumPy on my Mac laptop. Still, I run my application using Docker container. So Docker container, Docker image has all the required libraries. Okay. Let this complete, then I'll run the application and then I'll show you. Okay. Yeah. Stage one is done. It's copying the builder. It's whatever the artifact built and creating a image. Okay. That's it. Done. If you do Docker images, you should be able to see with the my app, right? Just few seconds ago, 13 seconds ago, this built, right? So I have created an image. Image is nothing but blueprint of your applications. Docker file, which is basically represent your blueprint. Okay. So we have done step one, created a Docker file. Step two, created a Docker image. Step three is deploy this Docker image. So when it is deployed, it is called container, right? So I'm gonna deploy the container. Go to README. You have the container command also here, right? Okay. So this will this will run in the background. This will if you want to connect to the bash, right? Let's say I'm gonna copy this. Okay, paste it, right? So before run it, I explain. So I'm gonna run the container image which is created. My app version this one. Either you can give like this or you can give image ID. Anything is fine, right? I'm gonna give image ID instead of image name, right? Or you can give image name. Image name should be my app colon 1.0000 slash, right? So that's the version. So I'm gonna image ID and click hit enter, right? Yeah, my application is running, right? If you want to see, let's go to the here. Just try to access that one. HTTP localhost port 8080. See, that's all done. I'm running my web application in my Mac laptop without installing any libraries into my Mac OS, right? So I'll just enter a Sidhu, right? It's just a sample application. You can just change it to the Go. It just print. This is a Streamlit application. Okay. So if I kill this one, let's say I'm gonna kill it, right? Right. So you won't be able to access, right? So right now I show interactive mode by default. Let's say if I want to give the run in the background, right? It's run always in the background. You just do -t, start it, right? If you see Docker PS, it will show the any container running, Docker PS. See, this is what running Streamlit application, right? So if you just refresh, this will work. Okay. So right now you can't kill it, you have to stop it, right? Docker stop and the container ID. Okay, it is stopped. So it is deployed, but it stopped. If you want to start same way, if you want to start back, Docker start this one. That's it. Just refresh, it should come back. Okay, let's go back to the presentation. Let's close it with conclusion. Okay, so what we have learned today, we learned the Docker basic commands, the Docker file, how to build Docker, how to deploy the Docker image, and also best practices. So if you follow this presentation, if you follow my GitHub repo and try to create images for different use cases, right? So this is sufficient to clear your Docker interview.